Good morning students, welcome back to digital signal processing class. In today's class we are going to deal with convolution. In previous classes we have talked about the block diagram of digital signal processing and some problem based on DFT and IDFT. In today's class we are going to see the meaning of the first thing is about convolution. So basically what is the meaning of the convolutions? If you had one signal like x of n, if you do have another signal I am assuming as like h of n, if I want to combine both the signal by applying some sort of delay in it, so when I want to go for the convolution between these two, what is the meaning of convolution? When I just want to multiply the first signal with second signal by applying the sequence. Like for example, if you do have 1, -1, 0, 1, if I do have next signal 1, 2, 0 and 0. If I want to multiply these two types of signals, I need to go for a specific method called convolution. So in convolution we'll be having two types of it. One is the linear convolution, second part is the circular convolution. So what is the meaning of the linear convolution? What is the circular convolutions? We come to know. The first thing we are discussing about the linear convolution. To do the linear convolution, first of all we should know what is the methods we are applying in order to get the signals get convolved. So signal gets multiplied or signal get delays. So in order to do these things you should keep in your mind the previous class signal and system, concepts of causal systems, stable systems, unstable. You should know about what is the linear dependent system, linear independent systems, all the properties of signals and systems you should know it. Then it will be easy for you to understand the further classes. So in today's class we are dealing with convolution. In that we are using one first formula for it. So if you do have the output, what I'm giving, I'm taking one system. In this, if I'm giving input signal, what is the input signal I'm taking? X of n. I need to get the output. So what I'm mentioning over here? H of n. So this is what impulse signal I'm taking. What is the impulse signals? H of n. If I want to multiply these two types of signals, so when I'm multiplying these two signals, what is the result I need to get? So either it is dependent, independent, whether it is depending on future inputs, past inputs or present inputs, I need to find out for that impulse sequence. So for that reason what I am writing, y of n is equals to x of n domain signal into convolve with h of n. This is the convolution, right? So in this what we are writing, y of n is equals to summation. So what actually this all system is all about, this is about the discrete systems. So what we are learning either digital or we are talking about discrete. So discrete means what? Obviously it should be summation. If you do have the continuous signal, what is the continuous means? It would be the integration. If you want to take the collection of data, when you had huge data, when you have to combine all the data collectively, in order to do that thing, we'll go for integration if the signal is continuous in nature. Likewise, when I'm saying it's a discrete, so that's the reason we are using the summation. So summation of n is equals to minus infinity to infinity. We are taking both the side, two-sided signal. From negative domain to the positive domain. From minus infinity to infinity, we are converting your n domain signal into k domain signal. For that what we have written, h of k into x of n minus k. So whatever the input signal is there, it is get delayed. So that's the things we wrote it, this h of n as it is, x of n minus k. After that what I am doing, I want to segregate this thing into two parts. So what I am doing in this, I am using a signal. What I am doing in this, I do have a signal like this. It's starting from minus infinity to plus infinity. In that I do have the origin 0. So this is what? Negative region, this is your positive region. So I am splitting this, whatever the range is there, I am splitting into two parts. So one starting from minus infinity to minus 1. What I am taking? Till minus 1. Suppose this is my input signal. So till this range, that particular region I have taken, I have written the same part. Clear? Plus this again, where it stop? It start from minus 1. So what is the next value after minus 1? It would be 0. So after minus 1, what is the next value I do have? It would be 0. Then I do have 1, like 2 till positive infinity. So that's the point I have mentioned. From 0 to infinity, the same signal we have mentioned. Now substitute the values of your summation. So what I'll write if I start from minus 2. So minus 2 if I put here, h of minus 2, n minus 2 minus plus 2. So this is h of minus 2, x of n plus 2. Likewise, I am taking next value as -1. There may be a lot of values will be present in this, so it's taking minus negative region. So minus infinity, I have taken two values in order to explain you what is actually is dependency, on which value it is going to depend. For that reason, what I have taken -2. Substitute here, wherever k is there, it is what? -2 x of n minus 2. So this minus and this minus will become plus. So that is what actually this is a k. So what is k value we are writing? Since it is k, so k minus infinity to 1, we got these two inputs. What is this? Nothing but, this is nothing but the future inputs, because we want to predict that particular function, how it is going to get the sequence in a future form. For that purpose, we put the value both the end, we got the value. Similarly, we got -2 -1. So what I am substituting in this? -2 is done, -1 is done. Next value would be 0, then I do have 1. For that reason, what I am doing? I putting the value of h of 0 here. So h of 0, n minus 0. So n minus 0, obviously it will be n. So this is your present input. So this future inputs we did, this is your present input. Next we are proceeding with your the past inputs. For that reason, after k is equals to 0, next value would be k is equals to 1. Substitute here, k is equals to 1, h of 1 x of n minus 1. That means it is depends upon the past input. So we do have these all particular values. So for this reason, we can say that your convolution of linear part depends on the past input, future input, and your present inputs. Based upon these three considerations, you can able to find out the value of that particular two signal which is in convolution, which is are going to be convolved from each other. So for that purpose, we are using some steps to analyze this thing. So in order to understand the steps, let us see some procedure analysis. How do we analyze that particular two sequence when do have a one input signal, another one when you do have the another input signal. So we'll see now. So students, so we'll see the next part, that is the steps for the convolution. So in that first part, what we are learning about the linear convolution. So we are doing the linear convolution with the help of the graphical method. So that linear convolution, how do we solve? So first thing, when we want the convolution of two signals, if you do have the first signal x of n, next impulse signals you are taking h of n. So first thing, we need to see its sequence. Suppose I do have the values x of 0, x of 1, x of 2, x of 3, like this I do have. This is my x of n. Similarly, next signal what I am taking, h of 0, h of 1, h of 2, I do have this signal. So this is my h of 0, this is my x of 0. So in this what I am writing, I am writing these two signals. So in this first step is what? Choose an initial value of n. So what is n actually? That is your y of n. So y of n samples we are saying it's n. That depends upon this number of samples of input signal and the number of samples of your h of n signal, another input signal. So in that scenario what we are saying? We are saying that choose an initial value of n such that to get y of n, if x of n start at n is equals to n1. So what is the first input signal samples we are saying? If it has n1. So suppose this is having some samples n1, second is having samples n2. It's not mandatory that the number of samples of your input 1 is similar to the number of samples of second input h of n. So it is not mandatory that both the sample size are equal. So it can be unequal. Like I said, 1, 2, 3, 4. I do have 4 inputs here. Here I do have 1, 2, 3. That means the size of first input and the size of second inputs is not same. So what is the resultant number of samples we'll get? So n is equals to, the resultant sample n is equals to is what? n1 plus n2. That means number of samples in first input plus number of samples in the second inputs. So when we combine both of them, we'll get the total number of samples in that particular sequence. So that you need to consider while you are solving the problem for linear convolution. Likewise, what is the second step? Express both the sequence in terms of your index k. So as we have seen the formula, when you had one sequence x of n convolved with another input sequence h of n, the resultant is what? Summation from infinity to positive infinity, h of k x of n minus k. So what is this k indicates? That is the index value we are considering in order to solve that specific problem. So that's what we have mentioned over here. So that index value we need to write it as k. That is the second input. Third step, first when we know that input x of n and h of n, we are just writing in terms of k. After writing these things, we just want to write the initial condition. What is the k value? K is equals to 0. First input you keep as it is. Second, h of n, you need to fold left hand side and right hand side. What is that folding? Folding means if you had the positive input, like if you do have this x of 0, x of 1, x of 2 and x of 3. So you want to fold it. Fold in the sense x of 0 is as it is. Suppose I do have this inputs. I'm having specific sequence like this. I do have it's at 0, 1, 2, 3. The same sequence, I need to go for this side folding. That means x is becoming minus x, and the same inputs I need to write it over here. So this is called as position folding for left hand side. So whatever the input signal is there, I just want to fold onto the right hand side. If the signal is there, if you do have that one, you need to fold for left hand side. So this is the way what we are doing. Fold h of k about k is equals to 0, obtain h of minus k. So previously it is actually what? H of k. Now we are writing h of minus k because we wrote the signal on left hand side. Or else shift by n to right. If n is positive, if you do have the n value is positive, shift to the right and left if the n is negative, and obtain, main criteria is that h of n minus k. So what is n minus k? N minus k indicates whether it depends upon the future inputs, whether it depends upon the past inputs. Based upon these inputs value, you are going to write that particular sequence. So for that reason we have mentioned we need to fold h of n minus k. Next step, multiply these two sequence and take the summation of it. So what we are doing, we are multiplying x of k with h of n minus k element by element, means each position element. If you do have the sequence like this, if I am having one input sequence like this, if you do have at 1, 2, this is my x of k. Next I am writing one more input sequence, I do have h of k. So this position by position means at 1, suppose I do have 2, at 1 I do have 3. That means this position value and this position value we need to multiply element by element. So this element and this element I need to multiply the respective element value, and then we need to take the summation for that particular folding of left hand side or right hand side. Next thing, increment the index n. So whatever the index n is there, if it's starting from n is equals to 0, then if we are moving to n is equals to 1, n is equals to 2, n is equals to 3. Likewise, we are incrementing the index value n and shift the sequence h of n minus k to right by one sample and do above steps. So this is the way we are doing. What we are doing, at every time you are folding your sequence h of k, and until and unless your sum needs to be 0. That means you should not get the positions of all your x of n and h of n, both the position, if you are multiplying, if you got the sum as 0, there you need to stop it. So this is the how we are proceeding your convolution of two sequence x of n and h of n. We are convolving and we are solving the problem by considering these all steps of this particular convolution. So just cross check these all steps, then we'll do some problem based on this. So students, so let's see the problem. So we had the problem like determine the convolution sum of the two sequence x of n and h of n. So they gave x of n is equals to 3, 2, 1, 2, and h of n they gave as 1, 2, 1, 2. So here they gave an arrow mark that indicates the position of it. So what is the position here? N is equals to 0, here n is equals to 1, here n is equals to 2, and here n is equals to minus 1. This is your positive, this is your negative. Similarly, here is what we'll write, n is equals to 0, n is equals to 1, n is equals to 2, n is equals to 3. First thing, we'll try to write its graph for it. So what we'll get this thing, so we can write like this. Here we do have x of n, here do we have n value. So what is this? 0, 0, 1, 2 and 3. So we do have these three values. So we'll write it at 0. What is this? It is maximum amplitude of that is 3. At 2, at n is equals to 1, the value is 2. So at n is equals to 1, we do have as 2. At n is equals to 2, it is what? 1. This is your 1. N is equals to 3, we do have it as 2. So we write it 2. So this is your x of n. Similarly, you want to draw it for h of n. So first thing we are drawing it, it's graphical representation. So h of n with respect to n, we are just want to write. So it's what, starting from -1, 0, 1 and 2. So these points we are writing. So at 1, at -1 it is what, actually it's 1. So we are mentioning it is 1. Likewise, we do have n is equals to 0, it's what, 2. So we'll write it as 2. N is equals to 1, it is what, actually it's again 1, again it is 2. Next thing, we need to write its lower limit. What is the lower limit is going to start? So lower limit is what here? First sequence, n1 is 0. So another sequence, what is the lower limit here is what? -1. So the main limit, n is equals to n1 plus n2. So that means start from 0, -1. That means the sequence should start from -1. Now, based on linear convolution or a convolution, what you can write? So convolution of y of n, if you want to write x of n convolves with h of n, I can write it as y of n is equals to summation k is equals to -infinity to infinity, right? X of k, h of k, x of n minus k. This we can write. Or else, if you want to delay the second sequence, k is equals to -infinity to infinity. What is the first sequence I can write? X of k, h of n minus k. This I can write. So I'm using this thing, the formula for convolution. So after writing the formula, what is the next criteria? We need to fold this particular sequence, or if you want to fold this sequence, you have to write first k index value. For that, what we are doing, we are writing the k index value. So now see, after writing k index value, what we'll get? So we'll use this two sequence. So first, what we have done, we have taken the first sequence, we draw the graph. We have took the second sequence, we have draw the graph. Then we want to write n value. So n1 plus n2 is equals to 0 minus 1, it is -1. Then for the convolution, we apply the formula, we wrote it. Next thing is that we need to draw its graph. So we'll draw the graph and we'll try to multiply the position value. That is the next step. As per the steps, we have done the starting 3 steps. Next step we are doing. So here we'll do it. So what I am doing, I am just want to fold this thing by mentioning by k index value. So this if I want to fold, what I'll get? This h of, suppose this is your h of k, right? If I want to fold it, what I can write for this? I'll write like this, and this factor will move this side and this factor will move this side. So we will try to exchange that particular terms over there. So this all will come this side. So at 0 it will be as it is. So what is the amplitude for that is 2. Then this 1 will come this side. So what is 1 value? Again it is 1. So at -1 it will come it as 1. This 2 will come this side, it will become -2. It is what actually it is 2. Again 2, and this -1 will become this +1. So what do I have this thing? I do have this as 1. So what is the value here? I can write x of -1. I am just shifting this side, minus k. So this, before doing this x minus k, I can first fold it so that I'll get n minus k. So I can write this is nothing but 0 minus k. Why I am saying 0? Because we are changing the position, right? So this is the first position we have changed. Likewise, we keep on changing the positions until and unless we will get the sum is equals to 0. So that point we will change and we will find out. So students, so we have taken the first sequence. So we do have the sequence, first one, 2 1 2 3, right? This is the first sequence we do have. Then second sequence. So what is the second sequence? H of k. So h of k we do have it as 1 2 1, and this is 2. So this is what we are doing. We are taking for n is equals to -1. What is the reason for taking this thing? Because we are adding n1 plus n2. So that is n1 is what? 0 -1. So the lower value starting from -1. So we fold it and we wrote it the first sequence. So what is the first sequence we do have? So 1 2 1 2. For the next shift, what is the next shift we do have? The same. The 0th position, we are shifting one value for it. The one consecutive term we are just shifting on left hand side. For that reason, what we are writing? We are writing this 1. Actually the position is what? 0. So that will be make it as 1. Then 1 2 1 2. That is as it is. This is for n is equals to 0 shift. Likewise, I'll take n is equals to 1. What is n is equals to 1? This one position will make it come to the second position. So here we'll start the first sequence. We got it as 1. Next, this 2 will come to this end. So this will be what? So this is what? 2. Again, this is 1 and this is your sequence 2. So this is for n is equals to 1. Similarly, I can take for n is equals to 2. So what is n is equals to 2? The sequence position, whatever the position is there, it will move to the third position. So start from 3. So what I'll start? I'll take the first number 1 and next I do have it as 2 at position 2. Next 1, next 0. So what is 0 value we can write it over here? I can write it as 2. So for which position we have shifted? For n is equals to 2, we have shifted. Your sequence keep on shifting on left hand side. So we are moving like this. Next thing, at third, now it is coming to the fourth position because we are putting for n is equals to 3. Third position is need to shift. So for every time you need to shift your sequence on n is equals to -1, we have shifted. So we completely fold it. Whatever the input sequence is there, we fold it and we write the sequence with respect to its origin values. Origin, then 1, -1, -2, -3 we get. Similarly, for the second time, third time, what is the last answer we need to write? Until and unless this position 3 sequence, if you can see over here, this 3 sequence, your complete this sequence needs to rotate to the left hand side. That means there is no possibility of writing the multiple terms over here. So till that time you need to write the sequence as it is. For that reason, what I'm doing, this 1 come to this point, this is 1, here is what? 3, 2 and 1. So 1, what is the next second term? 2, again 1 and then 2. This n is equals to 3 is done. Now n is equals to 4. For 4 means starting from 5, then 4, then 3, then 2. So what is the value over here? 1, 2, 1, again 2. Next n is equals to 5. What is n is equals to 5? Starting moving these terms over here. So what I can write for this? Starting from 6, then 5, then 4, then 3, then 2. So what is the value here? Fifth will come to this point. So 1, I can write here 1, then 2, then 1 and then 2. So now we'll try to multiply its respective term in order to get its summation. So we will multiply. So students, so now we need to take the respective summation for the value of n. So what is the n value? First thing, we know the summation y of k is equals to summation n is equals to minus infinity to infinity x of k h of n minus k. So we are taking the first value, k is equals to, what is the k value? First thing we starting from -1. So y of -1 is equals to, we'll try to multiply. So what will multiply? We'll multiply the first two, the respective position. So you do have this thing at 0, here is 1, here we do have 3. So what I can write for the first term? I can write 1 into 3 because I do get only this position which is matching for both of them. So we wrote the first one, this is 1 and this is your 3. So 1 3 is we got it as 3. So now k is equals to next case 0. So y of 0. Now look into the second part. When you had n is equals to 0, this graph and with respect to this graph. So what is this at 0? We do have here amplitude is 3, here is what? 2. So I can write 3 into 2 plus next at -1 do we have any value? No. Here at 1, yes, it is 1 amplitude, here is amplitude is 2. So I can write 1 into 2. So what will get? 3 2s are 6, 2 1s are 2. So 6 plus 2 it is 8. We got next value. Now k is equals to 1. At k is equals to 1, now see n is equals to 1 value. What is the n is equals to 1 graph? We do have this part is done. Now this is there. 0 position, the amplitude is 1. At 0 amplitude is 3. So we can write 1 into 3, a y of 1 plus first position we have done. So where we are, just this one. So at 0, this is 1 into 3. Now at 2, at this one. So what is 2 into 2? So I can write, so 2 into 2 plus. So now 2 into 2 is done. Now at 2, what is the value here? 1. At 2, here is value is 1. So we can write 1 into 1. So we got it as 3 plus 2 2s are 4 plus 1. Again we are getting it as 8. So we found k is equals to 1, k is equals to 0, k is equals to minus 1. What is the next case? K is equals to 2. So next case we are taking k is equals to 2 means we should look into the graph of n is equals to 2, because this is n is equals to minus 1, n is equals to 0 is over, n is equals to 1, now n is equals to 2. So you see at 0 it is 2, at 0 it is 3. So I can write 2 into 3 plus, now at n is equals to 1 is 1, at n is equals to 1 is 2. So I will write 1 into 2 plus, now at n is equals to 2 is 2 amplitude, 2 is equals to 1 amplitude. So what will I write? 2 into 1 plus n is equals to 3, it is 1, here is 2. So I will write 1 into 2. So I get 2 3s are 6 plus 2 1s are 2 plus 2 1s are 2 plus 2 1s are 2. So I get 12. That is my k is equals to 2. Now k is equals to 3. Likewise we will find k is equals to 4. So what is y? K is equals to 3, y of 3 is equals to, so now where is y of 3? This is our graph. So y of 3 is what? Starting from 1. So 1, here is 2. So what is this amplitude? 2 into 2 plus, now at 2 it is 1, at 2 it is 1. So I will write 1 into 1 plus, at 3 it is 2, at 3 it is 2. I will do write 2 into 2. So what will get? 2 2s are 4, 1 1s are 1, 2 2s are 4. So I get 9. We got y of 3. Similarly, we will find y of 4. So what is y of 4 graph we do have? This is our y of 4. So what is the position here? The position value is 2. So what is 2 amplitude? It is 2. At 2 amplitude it is 1. So I will write 2 into 1 plus, at 3 it is 1, at 3 it is 2. So I will write 1 into 2. So I get 2 1s are 2 plus 2, it is 4. Likewise I do find y of 5. Why I am not taking further value? Because till maximum it is this one, till maximum it is 3 is equals to 1, 3 is equals to 2. Here we do have 4 and 5, but here we don't have any position value for 4 and 5. So we need to skip that one. So we are not writing those values. So similarly, the last value we got n is equals to 5. Starting from third position, only we had one value because fourth, fifth position in our main sequence we don't have 4, 5th position. So that's the reason we are only writing at third position it is 2 amplitude, at third position it is 2. So what is the value? We can write 2 into 2. So 2 2s are 4. So we got this sequence. At the end we'll write all those values. So what is the first answer? 3, 8, 8, 12, 9, 4 and 4. So this is your sequence. So we'll write this sequence at the later stage. So before doing these things, once again you see what is the value we are starting? We are starting k is equals to minus 1, because the lower value is nothing but the position of your first sequence n1 and the position of second sequence n2. We'll take both the positions, we will add. So the value of 0 minus 1 is minus 1. So till what is the last answer? We got 4. If you want to write further, like n is equals to 5 I do have, n is equals to 6 if I'll take, I'm not getting any value which is multiplicable with this position, because after 3 4 will come. Here we don't have the fourth position. That's the reason we are stopping till n is equals to 5. After that sum is equals to 0. So students, so we got last answers. The total output what we'll write? We'll write 3, 8, next value we do have it as again 8. Then next is 12, 9, 4 and 4. So where is starting from? The value starting from this end, because this is your origin position, this is your minus 1 position. So this is your complete output of your function. So that we are writing in terms of your output y of n. So we have convolved the sequence and we obtain the sequence like this. There is one more approach to do these problems that we will see in the next class. Thank you for today's class.